I started the year by looking at the ideas of contained infinities and Escher's self-referential disks that become infinitely dense as you approach to its edges. Similarly, Poincaré's hyperbolic disks are used to define high-dimensional spaces. Shelly fossils that are stuck within the Portland stone can be thought as similar spatiotemporal objects, millions of years time scale that is contained in a finite stone. I started to map the ground voids onto the stone's surface to find out the total surface area. I remapped the areas onto a 2D projection. By unwrapping the digital scan of an ammonite fossil, I was able to project the fossil as 2D infinity disks that becomes dense at the edges. Mapping the projections of the fossils onto the surface of the stone created infinitely dense edges at the merging points that distorted and broke apart the surfaces and created areas of densities. From 2D objects, I started to look at the 3D versions of fossils, which involved looking at the formulas that derive the formation of an entire family of shelly fossils. One single formula dictates the different geometries with different parameters. I started to program my own fossils digitally by using the same formula, which enabled to create different variations. I created hyperfossils by changing the single parameter that defined one type of fossil to range of parameters to describe the different dimensions of what makes a shell. This resulted in temporal entities that is ever-changing, but describe what a fossil is more than its physical state. These hyperfossils that oscillate between multiple versions at the same time describes an occupied physical and temporal space of possible configurations. As I developed an understanding of how the mechanisms work, the fossil's configurations can be visible by lowering the frequency of feedback, which condenses them into main orbits. Having defined spaces, I created domains within the stone spaces that started to create a language that creates a spatial entity by using the 3D version of a scan and the 2D projections I have developed with the understanding of how they move within their orbits. I created a system where fossils project themselves onto the domain surfaces. By orbiting themselves, they project to the closest point. Where the distance to the closest point is not on the 2D domain surface, the projection jumps into the 3-dimensional space. The 3D fossils are reiterated as a spatial configuration in a continuous feedback loop. This resulted in fossils that drove themselves as 3D spatial entities within a void, which started to create architectural fragments through self-referential iterative processes. The language started to create different complexities and refined elements that suggested a sketching tool that can be further designed with. Fossils that drove themselves as architecture. At this point, it was important to question the fact that the drawing systems were in isolation without a context. The Jurassic coast is where the fossils are found, and its physical and temporal formation is the fossil's context. The Jurassic coast itself is a form of hyperobject. It is a high-dimensional entity that is formed over millions of years with different spatial and temporal sedimentary agents that were affected by the countless geological events. As difficult as to grasp the entirety of such multi-agent entity, writing my thesis on hyperobjects, I aimed to draw a grid system that represents the entirety of the Jurassic coast as a canvas for fossils to draw architecture on. I started to condense the Jurassic coast into samples and look at the whole coast as a hyperobject by separating temporal, physical, and spatial formation by looking at the scientific papers that describe the waveforms. From dating the temporal aspects to how the diagenesis of different stone types work and how then the tectonic tilting is actually creating what we see as the geological layers were the focus areas to translate into a drawing system. I assigned vectors that would translate each of these qualities into 3-dimensional physical space. During the drawing process, I created drawing rules that satisfy the Morton's principles of hyperobjects. Constructing the temporal information requires finding the most accurate way to date the age of a sediment. This can be shown through geomagnetic polarization, a barcode that shows the polar reversals of Earth. By matching them with the sedimentary data, the polarity of the remnant metals showed the north and south poles as remnant charges from the original age. Finding out about the polarity data of sediments enabled to establish magnetic information that translates temporal relationships into physical. Magnetic fields was successful as I needed a property that entangled all the agents but decays over distance and time. I started to assign charges to each sediment individually according to the analyzed charts. This started to form a spatial language that is then transformed into surfaces. Other qualities, such as the grain size or porosity, were included by changing the size of these petal-like surfaces. Sedimentary relationships and tectonic movements are added as angles. The grid system started to form a new spatial domain that simulates the Jurassic coast for the fossils to exist within in a three-dimensional coordinate. After establishing the system, the Jurassic coast grid is populated by sampling points to generate the building grid. A couple of iterations practiced the potential messing and testing how to design and model with the system. Fossils run through the grid system, allowing to project and draw architectural elements such as walls, ramps, and roofs. Using the fossil as my pencil, I started to design architectural fragments. Half of the surfaces are beneath the topography line, allowing for both additive and subtractive procedures to the landscape. Another experiment is showing the system on the cliff surface, imitating the eroded surfaces and future eroded volumes. Rigid or curved geometry can be created by offsetting the projection axis, creating flexibility in the design language. The scale of the projection defines whether the surfaces are complex or flat. Due to the relationships constructed from the magnetic fields, elements define a range of possible versions as the grid moves, creating endless configurations. This results in an architecture that is always uncertain and constantly changing, adapting. Having simulated the entirety of the Jurassic coast, the materiality translates into sections as rock sediments. Surface qualities reflect the rock properties by scaling up the microscopic surface qualities into the building scale using displacement maps generated from scientific papers where they appear on the facades and walls. The materiality consists of stone, recycled plastics, and recycled aluminum pieces. Plastigglomerate is a trace of human nature interaction where natural rocks are partly merged with plastic waste, forming the fossils of the future. Plastic architectural elements that are drawn by the fossils would eventually be left behind as the humans' fossils. Material palette of the rocks are used to design plastic tiles and bricks which are used throughout the building. After running all the tests, a final building grid is established. The proposed building grid is dynamic and is part of a larger grid representing the entirety of the Jurassic coast, reflecting the rock clusters. Each is assigned a program consisting of a library, auditorium, fossil museum, workshops, and archives. As described by Morton's theory regarding the hyperobjects, the project ultimately aims to translate the principles of hyperobjects into architecture in both geometrically and mood and experience. Viscosity regards to each architectural element being stuck to the grid, which makes them move and alternate as the grid changes. They can only exist as connected to the grid. Non-locality regards to that any point where the architectural system changes. It affects the entirety and doesn't depend on a single point. Interobjectivity comes with the space that architecture occupies as a resulting entity, a mediator among the surface agents. Phasing regards to the qualities of architecture that describe the intangible mood and experience of the spaces, which are only visible to the occupier through phased patterns. Initial tests and iterations suggested a changing architecture. These qualities are initially tested with moving fragments. The change is also tested with more natural processes such as erosion and eroding surfaces. The process of exploring how to convey hyperobjectness of architecture is settled with the third test as phasing switches. Since every version is completely different configuration, the design of alternate versions would be according to the occupational needs of the spaces. A version that requires a design change due to the intangible qualities of architecture, such as humidity, coldness, warmth, or brightness. The architecture would switch to a more suitable state that would satisfy these occupational needs. The qualities of architecture is reminded to occupants with elements that heat up or freeze, such as the cold water running balustrades. The small elements and furnitures are also drawn by using the system. The architecture emerges in multiple scales as surfaces of fossils translated to human spaces. The design resulted in 7 buildings that offer multiple versions each. The diagram shows 2 different states for each, showing plans and phasing transformations as they alternate. This results in an architecture that has undefined boundaries, merging and separating as an entity as they are affected by their contextual circumstances. Emerging at the edge of the cliff, every time a new fossil is found, a potential room exists somewhere along the Jurassic coast.
Human civilization stretches back thousands of years. But compared to the age of the Earth, we humans have only just arrived.